mine, but all of them are customers, just so that you know. And I should have done this at the beginning. This is the dry pigments right here that I brought. This is pigment dispersion. We're going to talk about this. These are filler pigments. Different oils for the oil paints, shellacs, watercolor binders, oil painting mediums, solvents. This is oil painting medium 2. This is Damar resin. I'm sure you guys know what Damar resin is. And I brought Damar resin here in one solvent, and this is Damar resin in turpentine, also known as Damar varnish. This is Damar varnish too. The color is different. I'll explain why later. And these are paints and oil sticks, which I brought for you guys to have at the end of the talk. So basically, that's the array of things I have. So, natural synthetic is great. What else can we think about if we're to think about pigments? For example, if you're making paint, okay, you got pigments, you're in your studio, and suppose I'm there, and of course you have no idea what you're doing. What do you think you need to know about the pigment before making the paint? How to mix it? Is that what you said? I'm sorry. Yeah, how to mix it. That would be, just mix them together. And we'll get into that later, but I'm a little keen on knowing other things, which I want to get into in the first part, because as you'll see, mixing is kind of very, very easy. It's not the hard, it's not the hard part, but if you're going to be working with pigments, there's a few things you should know. I'm sorry.
How much material, like how much pigment, how much binder?
To use, right? The proportions. Okay, that's true too. I'm just going to make a note because I want to come back to this later. You want to know about the proportions. Can I borrow a pen? Anybody? I'm sorry. Thanks, Jean. Thank you. Proportions, how to mix. What else do you think you should know before even you starting to make the paint?
Maybe the toxicity of it?
That's a good point. I'm sorry, you have your
Yeah, it's just how well it mixes, because some pigments are more hard to dilute than others.
Absolutely. She says toxicity, which one dilutes. Now we're into what I'm looking for here. Which one are toxic? How they dilute. For example, I would want to know, are they opaque or transparent? How I can know, if they are opaque, transparent, that kind of stuff. For me, the most important thing when I give this talk is to explain to the people about the toxicity of the pigments, which one are toxic and which one aren't, because some pigments aren't toxic. You will hear people saying, oh, don't work with pigments, all of them are toxic, but it's not true. Some of them aren't, that you can work with them safely. So which ones are, which ones aren't, that's always, before I even start mixing, it's something I will cover, and why. And, how they dilute, how you can use them, what you should know about before you start to mix them, because the fact is, pigments are pure color. So if you don't know what you are doing before you start to mix them, there's a good chance you're going to make a big colorful mess out of your studio, because they're very, very concentrated, as you'll see. Especially if you're only used to buying tube paint. All right. So unfortunately, the best way I found to explain this is we're going to need to do just a little bit of that. Some of you here have a science background, or just a little bit. You remember science from high school? That's all you need for my day. Okay. Do you guys remember, where is it? It's here. This line here, there was a line. You see these? This is elements. These are the table of elements. You guys know what an element is?
Yeah.
Yeah. You want to tell me?
It's far.
I'm sorry?
It's far.
An
In
element?
my head.
Yeah, that's okay. You did your part already.
Well, isn't it like a basic component or something?
That's right. It's a basic component. It's basically the matter is molecules. Molecules is a mix of element, and element is what was taught as to be an indivisible part of the matter. Now we found today with modern chemistry and physics that it can be further divided, but for today we're going to consider this as the basic building blocks of matter. For example, if I'm talking about steel like this, yeah, is a mix of iron, this one, and carbon, this one. Everything pretty much is a mix of these two. We call molecules. So elements basically, and I'm making a vulgarization, but basically you have two types of elements in the world, in the table. You have them here. I don't know if you guys can see the picture, and you have them here. Do you know the difference between them and them? These shiny ones and these weird looking ones? Yes, some of them are in gas phase, and by the way, if you heat up anything, it will go to a gas phase. Either gas, solid, or liquid are the three phases, and all elements can be at either or, depending on the temperature. So it's kind of not what I'm looking for, but the gas ones and those ones, the carbon, sulfur, and everything ones, as opposed to those ones, the calcium, the magnesium, you know, the molybdenum, the cobalt. What's the difference between them?
Like 5 years ago. Oh my god.
I'm sorry. There was a. Do you remember there was a stairway?
Yeah, I remember the stairway. I just don't know what it means.
That's right. I'm looking for what it means. That's okay. Have a look at the picture here. I know they're far. And have a look at the picture here. These are weird looking ones, and they kind of all look the same.
We have an answer. We have an answer.
Okay. You were.
Metal
Yeah.
and non-metal?
That's right.
Jeez.
Did everybody hear?
No.
She said the perfect answer: metal and non-metal. Everybody heard this one?
Yeah.
Okay.
So you're saying those are the two types of elements?
I'm making this super simple,
Okay.
but basically, yes, that's what I'm saying. In the elements, you got metals and you got non-metals.
So the fact about gas, that didn't, like, you said somewhere like vapor is.
I'm sorry.
You said somewhere like vapor.
Yes,
Yeah.
because in Earth, basically the temperature is between around 30 degrees. So at a 30 degrees temperature, some of them are liquid, like for example, mercury, Hg, is a metal, but it's a liquid metal at our temperature. Now, if we could go to outer space together with mercury, it would become a solid, because there is colder. So whether it's a liquid, a solid, or a gas is only depending on the temperature you are at. Because all elements can be liquid, solid, or gas. It's only depending on the temperature. Because she said that in the beginning, you know, pointing out that difference. And basically, that's what I answered, that it can be either or. You understand? So metal and non-metal. For example, carbon. Metal, non-metal? Non-metal. Sodium. Salt. Sodium. Sodium chloride, but sodium. Magnesium.
Magnesium is metal.
Yeah, sodium is metals as well. They are soft metals. First line here. And of course, you know, iron, cobalt, manganese. Does that ring a bell? These are all metals. Sulfur. Guys, sulfur, what do you think? It's not a metal. No. You see that crystal here? That yellow one? That's sulfur. It can be a gas too, but in this case, it was they made it into a rock. So all of them are non-metal. Chloride.